welcome to our channel. So this video will focus on timing diagram. Okay. So what is diagram? Diagram is a graphical representation. Okay. So whatever information you want to say, that information convey in the form of graphical. Okay. So it's a diagram. What is timing? The information is changed with respect to the time. Okay. So here you consider the information is a instruction. In the instruction, the form of instruction is varied with respect to the time. So the information is posed in a graphical way. That's called as timing diagram. So this timing diagram basically split in 3 cycles. So 3 cycle of functions. The first cycle is machine cycle. Second cycle is instruction cycle. Third one is T state. Okay. So what is machine cycle? So machine cycle is how many times the instruction is accessed the memory or IO devices. Okay. So that is called as a machine cycle. The next one is instruction cycle. So the time required to execute the instruction. That's called as a instruction cycle. The third one is T state. So in these two, machine cycle and instruction cycle, this function is based on the clock. Here we are applying the multiple number of clock frequencies. In a single clock cycle is called as a T state. Okay. The T state is referred in T1 and T2. So T1 and T2 is a T state. So these are the 3 cycles. Is very important to draw the timing diagram. That we will discuss one by one. Okay. So in the timing diagram. Next, it's accessing the microprocessor, accessing the data or program or IO devices. So where the information get in microprocessor, the first possibility is getting the information from program memory. The second possibility is getting the data from data memory. The third possibility is getting the information like data or control signals from IO devices. Okay, there are 3 possibilities of getting the informations. Okay, so program memory or data memory or IO devices. Based on that, we can split in the table. So in the machine cycle, basically classified into 5 types. Okay, the first one is output fetch. Then next one memory read. Third one memory write. Fourth one IO read. Fifth one IO write. Okay. So these 5 signals may be vary the functions based on the values. So IO slash M bar, S1, S0, RD bar, WR bar, INTA bar. So this table is referred to the status. So status of the timing diagram. From where getting the data, memory location or IO devices, whether the information is read or write into the microprocessor. Okay, that will check with the help of the table. The first one is output fetch. So fetching the output, fetching the program instruction. Okay, so that instruction is fetched from the memory unit. So that instruction is fetched from the program memory. Okay, just read the instruction, not write. Just read the instruction from the program memory. So whatever instruction stored in program memory, that instruction you can read and decode and execute. So here you put 0. That 0 represents the information get from memory. Okay, here I am writing IO slash M bar. So this value equal to 0. M is a active low signal, only enabling the memory. Suppose this value equal to 1. So in this case, IO is enabled, memory is disabled. Okay. The first condition is output fetch. The instruction you can fetch from the memory. Okay. So these 2 signals are mentioned the status. Okay. So read function or write function or fetch function. The first one, you can fetch the information. So here the status is S0 and S1. Both the values are 1. Okay. Remaining 3 signals of read the value or write the value or any enterprise. Okay. If any enterprise in microprocessor First you send the request signal, then the microprocessor posts the acknowledgement signal. Okay, so this lost signal only used for the interrupt case. So now go to the read board signal. So here read the instruction from memory. So you put here 0. So 0 is the active low signal. Read function is enable. Next one, write. There is no write function in the first output fetch. So this value goes to 1. So disable the write. So interrupt value also disable. Next one, memory read. So in this case, in the instruction itself pausing the memory, so you can read the data from memory itself, not IO devices. Okay, so here the control signal is 0. So 0 represent for read the content from memory unit. Then the status represent 1 0. So S1 value 1, S0 value 0. So 1 0 for read the information from memory unit. So here you enable the read signal. Rest of the two signals are disabled. The third one, memory write. So here also you are choosing the memory unit. So here put it as 0. So next the control signal is 0 1. S1 value 0, S0 value 1. It's represent the write function. Okay. So write the data to memory. So whatever content present in microprocessor, that value is passed to the memory unit. That value is write into the memory unit. Okay. So next read signal. So here read is disable, write signal enable. So interrupt disable. Next one, IO read. So far we getting the data from memory unit, but these two signals is referred to getting the information. So like input or output in a IO device. First you enable the IO. So IO value equal to 1. So in this case you only enable the IO. You are getting the data from IO device. Then here only performing the read function. So read function means 1 0. So 1 0 represent the read function. Okay. So read only enable. Remaining two signals are disabled. So next one, IO write. So here also enable the IO value. The status is 0 1. And read value disable, and write value enable, and acknowledgement also disable. Okay. So based on this status signal only you can draw the timing diagram. Okay. So it's a basic introduction about the timing diagram. So next video we focus on how to draw the output fetch and memory read and memory write, IO read and IO write. That will discuss one by one with the help of the timing diagram. Okay. So thanks for watching my channel. Thank you.